Hey everyone, so today we are talking about volume and surface area of spheres, cylinders, and cones. So we're going to start off with cylinders, move into cones, and then finish off the day talking about spheres. Your assignment is just going to be about volume and not surface area, but it's important to know both of them in order to use the information we know about these shapes to answer the problems you'll be given for today. So first thing you want to do is make sure that you have a copy of this PDF that you should see in Schoology. Save to your Chromebook. If you have a printer, you can print it off so you have a paper copy of it. However you best want this sheet, make sure that you get that copy. All right, so starting off with cylinders, we're going to look at surface area and then move into volume. So to find the surface area, we have this equation, 2 pi r squared plus 2 pi r h. So that 2 pi r squared is going to give us the surface area of both of the top and bottom circles. So thinking back to what we have as our area for just a circle, that's pi r squared there. We have two circles on the top and bottom of our cylinders. So we need to have that 2 pi r squared to get the two areas of those two circles. And then if we were to unwrap this cylinder, the middle portion here would come out as one big rectangle. And so we know that the area for a rectangle is length times width. But in this case, it's wrapped around a circle. So we have to have that 2 pi r to get the distance around our circle, our circumference, and then we multiply that by the height of our cylinder. So the length of our rectangle is the same as the circumference of our circles. So let's go ahead and solve this one. If I know that the radius is 11 yards and that the height is 26, I'm just going to plug all of that in. So 2 pi r squared plus 2 pi r h. And I'm going to plug 11 in for r. 2 pi 11 squared plus 2 pi 11, and then h is 26. Now, I'm going to grab my calculator here quick so that we can solve these. Because we want to be as exact as possible, I'm going to use my graphic calculator so that I can get that pi symbol in my equation. Okay. So we have 2, and then pi is going to be the second function of our little caret here. You can see it right there in the yellow. So second caret. There we go. And then 11 squared, I know that that's 121. So for this side, I get 760.2654 plus, I can actually just add on 2 pi and then 11 and 26. And total, that would give me 2,557. And I think they want you to round to the nearest tenth, so we'll round that 2 up to 3. The important thing is what units we're going to use for this. And since we're talking about surface area, we have our r squared here as well as our r times h. Our units are yards squared. Just like when we were talking about regular area, we still have a square on our unit. So we know that that is going to be 2,557 and 3/10 yards squared. Sometimes they might give you the diameter of your circle. Well, that just means we need to cut this in half. So half of 15 would give me 7.5. If they give you the circumference of the circle, well, we already have part of what we would need then. We know this part right here. Or you can use circumference to solve for your radius. So let's say that we get a circumference of, I'll use the back side here. Let's say we get a circumference of 45 is our circumference. And I want to figure out what my radius is. Well, we know that the equation for circumference is 2 pi r. So 45 is equal to 2 times pi times my radius. Well, the quickest way to solve for r is to get it by itself. And remember that pi is just a number. It's a symbol that represents a never-ending decimal. And so we can actually divide both sides by 2 pi. So we'll get that our radius is 45. 45 divided by, I'm going to use parentheses so it does both of these together, 2 pi. And we get that our radius would be 7.1619, yada yada. I'm just going to round to the nearest tenth again, 7.2. And I didn't have units on here. It could be inches, could be anything. This was just an example to show you how to go from circumference to your radius so that you can plug that in for your equations. Using the other areas, perimeters, those kinds of things, you might have to use some of these other equations to solve. All right, so the next thing we need to look at now for cylinders is their volume. Similarly, remember that if you were to be given the circumference or a different measure of our circles or the rectangle, we can use any of those areas in order to find the specific length we're looking for. For the examples I have here, we are given the radius and the height of our cylinder already. So we can go ahead and use our equation that volume equals pi times the radius squared times the height. So we have volume equals pi r squared h. Now 18 is going to be our radius, 15 is our height. We'll plug those in. We know that our volume is pi times radius, which is 18 squared, times 15. And again, you could plug this all into your calculator all at one time. So we would take our calculators here, and we would type in pi times 18 squared times 15. Now, notice I've moved the square this time into the parentheses instead of outside. I don't think it would make a difference. I just want to make sure that this is taking 18 squared, so I've put it inside the parentheses this time. And we get 15,268. 15,268 and 14 hundredths. So I'm just going to round this up to 1. Now, the important thing, though, is to remember that volume has 3 measures. We have our radius twice. We have r, and we have h. So for those measures, when we're talking about our units for volume, we have 3 sides that we're multiplying together. So that means that our units need to be cubed. Cubed means that I've multiplied them together 3 times. And remember again, if you are given a different measure than the radius or the height, you can go through that method of solving for any of the side lengths using those area formulas that we know so well. All right, so that's cylinders. Let's move on next to our next shape. All right, so our next shape we are talking about is cones. So we're going to go through surface area, and then we're going to talk about how to find the volume of a cone. Very similar to those cylinders, but now we have to think about the shape that's being wrapped around it a little bit differently. Our shape that's being wrapped around this base circle here is no longer a rectangle, it's actually a triangle. And so the way that we can think about it is to think of this as kind of a right triangle inside of my cone. So with that, let's go ahead and try and find that surface area for this number 7 here. We're given the equation pi r squared plus pi r L. So now remember, we can break this down and look at our other equations and see where this one comes from. We know that a circle has a circumference of 2 pi r. And I only have one circle here. However, a triangle, to find the area of a triangle, you use 1/2 base times height. So that 1/2 cancels out my 2 for this pi RL here. But r is half of my base, and the height is kind of this imaginary line inside of here, which we would be able to find using the Pythagorean theorem. We don't need that though for this one. L is the outside length of our cone. All right, so we can see where the parts of that circle play into finding the area, or the surface area, sorry, of our cone. Now let's actually solve it. We know that our radius is 7, so we have pi 7 squared plus pi 7, 11.4. Well, I know this is going to be 49 pi, but 7 and 11.4, oops, that should be a plus in there. 7 times 11.4, 79.8 times pi. I can add those two together to give me 128.8 pi. But I want this to be the exact decimal, so I'm going to go ahead and multiply that by pi. Oops. I'll take 128.8 multiplied by pi. And I get 404.637, so that would round up to 0.6. Remember, our surface area, just like area, is our units squared, so this would be meters squared. All right, the other thing to talk about when we have cones is to talk about their volume. So now we have the equation of 1/3 pi r squared h. Now, this one's a little bit more complicated. It talks about some different parts that we maybe haven't quite covered just yet. But remember, we're taking the volume, how much space this cone is going to fill up. Now, notice that it says that this actually only covers 1/3 of what our cylinder was. That's because a long time ago it was proven that every cone is actually 1/3 of what that same cone would be, but as a cylinder. So think about taking just a third of a can of soup, right? That would be what would fill up the same dimension-sized cone. So with that, let's go ahead and use this equation. We have 9 yards and 17 yards, but now this time we'd have to find our L if we were to find surface area. However, for our volume, they only want the height and the radius. So we can actually just go ahead and plug this in as it is. So 1/3 pi r squared h, and we know that r is 9 and h is 17. So again, I can plug this into my handy calculator. We have 1/3, I'm just going to hit enter on that, times pi times pi, and I know that 9 squared is 81, times 17. And I get, with all of that multiplied together, 1,441. And that 0.99, I think I'm just going to leave that as it is. If your Delta Math assignment were to ask you to round to the nearest tenth, you would just round this up to the next one. So this would be what we would say approximately 1,442. And now we need to label our units. Remember that volume has 3 sides that we're considering here. We're taking 3 lengths times each other. So that means that this would be yards cubed. All right, we've got one more shape to cover here. Let's go ahead and move on to that next shape. All right, so before we get started with talking about the volume and surface area of spheres, we want to first talk about the parts of a sphere. Now remember, a sphere is a solid, just like all of our other shapes we've been talking about today, but each point is equidistant from the center point. So just like a circle, but now we're thinking 3D, right? Now, the different parts of this circle, we're still going to have our diameter, this full line that comes through here. We still have that. And we also still can take that diameter divided by 2 to get a radius. And again, that center point is always going to be the center point, whether we're talking about a circle or a sphere, there's still a center point. The last thing, though, is to talk about the great circle. So there's something we call the great circle in here. And it's this dotted line that cuts our sphere into two hemispheres or into two halves. So if you've ever taken like a golf ball and chopped that in half, you've taken a sphere and broken it into two hemispheres, two half circles, or two half spheres, I should say. So let's talk about how we use that information to actually find the volume and surface area of some of these shapes. We want to find the volume or surface area given the different problems here. First, let's just talk about volume. The equation for volume is 4/3 pi r cubed. So remember when we looked back at our circle equations, we had pi r squared for just the area of a circle and 2 pi r for the circumference of the circle. So where does this 4/3 pi r cubed come from? Well, it actually comes from taking the area of what would be kind of these inner circles, and we know that there are 360 degrees in these circles, and so we can use some of those numbers to create a proof that would show us that this area equation is equal to 4/3 of our area times one more radius. So knowing that that is our equation, let's move on to actually using it now. So we would have our volume is 4/3 pi r cubed. So we're going to take, we have our radius already. They gave it to us, it's 7. 4/3 pi, 7 cubed. Again, I can just take and plug this into my calculator. And so I'm going to do that here. Couple of things though with our calculator this time. We need to do a number cubed. So I'm going to do 4 divided by 3 in parentheses times pi, so second pi. And then I need to multiply that by 7 to the third. Now, there's no special button, and there's no second button that will give me to the third power. So I need to use this little caret key, or this up arrow, to the third. And that gives me 1,436. So volume equals 1,436, 1,436 point. And if we wanted to round this to the nearest tenth, we would say 8/10. Again, this was in inches, so our units would be inches cubed. Again, we can go through the same methods though. If we're given circumference, we can use that circumference equation to solve for our radius just like we would any other time, and then use that radius to find the volume of these spheres. Surface area now though, 4 pi r squared. 4 pi r squared. Well, if we take a look at our equations sheet here, we said that the volume is 4/3 of our area times another radius. This time though, it's just 4 times our area. If you look at our equation sheet here, it has to do with jumping from the third dimension to the second dimension, or the second back to the third dimension. There's a long proof that talks about this. I'm not going to go too in depth on this one either, but it's definitely an interesting one if you wanted to go and check it out. So to use this surface area equation, again, we need to have our radius. So this first one gives me the radius. The second one doesn't though, so I'm going to use this one this time. And I am given 24 millimeters for my diameter. Diameter 24 millimeters. Well, to get my radius, I just need to chop this in half. So my radius would be 12 millimeters. Now I can go ahead and plug that in for surface area, and I'll get 4 pi 12 squared. Surface area equals, type that all into my calculator, 4 times pi, and I know 12 squared is 144, so that gives me 1,809, and rounding to the nearest tenth, 6/10. And we said our units were millimeters. And because we're talking area, our units are squared. One last thing I want to point out is the difference between the hemisphere and the sphere. So, like I said before, we have 1/2 of a hemisphere is, a hemisphere is 1/2 of a sphere. So if we look at our equations here, you notice that the volume that a hemisphere has would be half of the volume of a sphere, right? If we take 4/3 and multiply it by 1/2, you can do this one of two ways. You can just multiply it as it is, tops together, bottoms together, 4/6, and reduce that down to 2/3. Or you could say, I know that 2 goes into 4 twice, and still come out with that 2/3. So we still have the volume, seems like it would make sense, but the surface area is only 1 less pi r squared than our sphere. And that has to do with the fact that we still have this here whole area of this circle to cover. So the outside part of my hemisphere is half of the outside of this sphere, but I need to add the area of this top circle, which just so happens to be pi r squared. So if I were to take that 2 pi r squared, add on one more, I would get 3. Just a quick note on where those come from. You know how to plug these in and solve. It's just like for the sphere. Again, if you are given the circumference or any other measure of your circle, you can use that to solve for the radius and then use that to plug in for volume or surface area. As always, if you have any questions, don't hesitate to ask. And with that, I'll see you next time.